Hi everyone, myself Abhinav. I'm from Visakhapatnam. I'm currently pursuing my Bachelor of Technology in KL University Vijayawada in CSE Honors Department, and I'm doing peer mentoring course called Computer Networks and Security, and it's a small video blog in which I want to explore about a topic called underwater sensor networks. First of all, introduction about underwater sensor networks. Technique of sending and receiving message under the utilization of sound propagation in the underwater environment is known as acoustic communication. Underwater sensor networks have a number of vehicles and sensors that deploy in a specific area to perform collaborative monitoring and data collection tasks. Traditionally, for the monitoring of ocean bottom, oceanographic sensors are deployed for recording data at a fixed location and recover the instruments at the completion of tasks. The major disadvantage of traditional approach is lack of interactive communication between different ends. Recorded data can never get during any mission. In case of any failure, recorded data will be destroyed. Underwater sensor networks support a wide variety of applications. For example, aquatic surveillance, river and sea pollution discovery, monitoring, oceanographic data compilation, and commercial exploit the aquatic environment. Underwater sensor networks can be utilized in any scenario from underwater warfare to the monitoring of environmental conditions. Underwater sensor networks face constraints like limited bandwidth, high propagation delay, 3D topology, and power constraints. Radio and optical waves, which are not feasible for communication at each point of the ocean. Under the entire limitations, underwater sensor networks can only utilize acoustic signal, that is a technique which is utilized by nature from the birth of ocean. Speed of sound is considered constant in an underwater environment. However, speed of sound is affected by temperature, depth, and salinity of underwater environment. Underwater acoustic channel frequencies spectrum, especially on mid frequencies, is heavily shaped by various acoustic users in underwater environment. Underwater sensor network nodes are not static like ground-based sensor networks nodes. Instead, they move due to different activities and circumstances of underwater environment, usually 2 to 3 meters per second with water currents. Sensor data is meaningfully only when localization is involved. Another major issue that is affecting underwater sensor networks is energy saving. Because of nodes mobility, the measure of offered energy competent protocols become inappropriate for underwater sensor networks. Different protocols regarding line-based sensor networks are, for example, different directed diffusion, gradient rumor routing, TTDD, and spin. However, because of mobility and rapid change in network topology, these existing ground-based routing protocols cannot perform efficiently in underwater environment. Optimal packet size is depending on protocol's characteristics like offered load and bit error rate. Poor packet size selection decreases the poor performance of network throughput efficiency, latency, and resource utilization and energy consumption in multi-hop underwater networks can be greatly improved by using optimum packet size. Uh, in addition, classification of routing protocols of UWSNs and their comparison in terms of bounded latency, multipath load balancing, energy consumption, geographic information, communication overhead, and the time complexity. Similarly, data delivery ratios for single multipath and the strengths and weaknesses of MAC protocols with the user topology are compared. Uh, as you can see, the underwater sensor networks architecture. As you can see the below figure, underwater networks physical layer utilizes acoustic technology for communication. Limited bandwidth, capacity, and variable delays are characteristics of acoustic technology. Therefore, new data communication techniques are efficient protocols are required for underwater acoustic networks. Designing their network topology requires significant devotion from designer. Because underwater network performance is generally depending upon topology design, network reliability should increase with efficient network topology, and network reliability should also decrease with less efficient topology. Energy consumption of efficient network topology is highly less as compared to incorrect and less efficient topology design of underwater network. Design of topology for underwater sensor network is an open area for research. Uh, as you can see the figure, there is offshore sink which is going to uh, surface station, and there is surface sink which is going to reflect the surface station, and the horizontal link which is going to the vertical link, and underwater sensor, and there is underwater sink. These are the major components which we require for underwater sensor networks. Recently, we have observed that there are some issues and challenges regarding underwater sensor networks. The issues and challenges regarding underwater sensor networks are described, which makes underwater communication hard and problematic as compared to terrestrial sensor network communication. There are some differences between terrestrial sensor network communications are cost, deployment, and other warfare networks, which are being a major issue for the underwater sensor networks. In underwater sensor networks, there are some selections for communication, power consumption, distributed localization, environmental effects, media access control, and network routing protocol still need to address. These problems require attention from academia and research community. Following section describe efforts which are made by researchers to address these issues. First of all, the environmental effect, which is causing the marine organisms are affected due to anthropogenic sound, which is emitted in the underwater environment. Due to this, only acoustic communications meets the requirements of underwater communication due to less attention and low absorption in sea water. As you can see in the below figure, the figure varies. The temperature of sea surface is much higher as is compared to the bottom temperature. As shown in the figure, temperature is falling with depth and becomes constant. Velocity of sound is also affected with increase in depth, salinity, and temperature, because these are the major factors that affect speed of sound in underwater environment. The effect of these environmental parameters can be observed in three domains. The first domain, the impact of temperature, is dominating as compared to the other parameters. But in the second domain, both depth and temperature are dominating factors upon the sound speed. In the third domain, the sound speed is purely dominated by the depth. Speed of sound is also depending upon salinity. Speed of sound increases with the increasing salinity of the seawater, but the shape of the curve does not change. As you can see in the graph, uh, we have took the y-axis at depth meters and temperature as x-axis. The temperature, the the depth goes high to the temperature and comes down again due to the issues occurred by the underwater communication networks. These networks must utilize such kind of sound waves which do not affect natural acoustic communication and the organs of the water creature in the deployment of underwater communication technique. Utmost care must be taken regarding the life of marine animals and their communication. It is still an open area. Research needs for solution from research community. And we can design the underwater sensor network in such a way that we can see the architecture in a clear cut way. So the first one is underwater sensor networks in two dimensions. Deep ocean anchors are utilized for the collection of sensor nodes in two-dimensional underwater sensor network architecture. Anchored underwater nodes are use acoustic links to communicate with each other or underwater sinks. Underwater sinks are responsible to collect data from the deep ocean sensors and provide it to offshore command stations using surface stations for this purpose. For this purpose, underwater sinks are provided in the company of horizontal and vertical acoustic transceivers. Purpose of horizontal transceivers is to communicate with sensor node to collect data or provide these commands as have been received by offshore command station. Although vertical transceiver is used to send data to command station, because ocean can be as deep as 10 kilometers. Vertical transceiver should contain enough range. Surface sink that is equipped with acoustic transceivers has the capability to manage parallel communication by means of multiple organized underwater sinks. Surface sink is also equipped through extensive range radio frequency transmitters to communicate with offshore sinks. And the other thing is we have some we can monitor through the ocean environment, and there is ocean mapping too, and we can navigate through the ocean like in which we can see the sensors with the acoustic link communications, and we can monitor through the ocean in order to make the underwater sensor networks more probable, propagated. Uh, prop, while coming to the propagation phenomena of underwater sensor networks are the communications regarding underwater environment is a complex phenomenon because a lot of environmental factors affect acoustic communication. Due to these factors are variable like long propagation delays, environmental noise, path loss, Doppler spread, and multipath effect. Underwater environmental factors make acoustic channel highly variable. They also create bandwidth dependency upon both frequency and distance between nodes. Generally, ocean is divided into two parts. These are shallow and deep ocean. Shallow and deep ocean characteristics are described like shallow oceanographically acoustic channel because of high temperature gradient, multipath effect, surface noise, and large propagation delays as compared to deep ocean. Underwater environment, major propagation factors affecting the acoustic communication are described in subsequent sections. There are some major application scenarios and routing strategies. The first of all, the application scenarios are most applications of UASNs are related to underwater collection, where the surface units are used to collect data transmitted by the underwater sensor nodes. Therefore, application scenarios can be classified into single sync, multi sync, and zero sync according to the number of syncs that a UASN uses. As shown in the first figure, uh, in a single sync based UASN, there is only one sync node which can be static or mobile. As you can see, number of packets are linked to the each other. Coming to the next figure, the static sync node is fixed on the bottom of the ocean. The mobile sync node moves the collect data from the sensor nodes deployed in the ocean, as shown in the figure 2. As shown in the figure 3, the network topology of multi-sync based UASN, where two or more sync nodes are used to receive packets collected by sensor nodes. A sensor node only needs to transmit the packets to one of the sync nodes closer to the node. Sensor nodes in a multi-sync based UASN can also be static or mobile. In a zero sync based UASN, server functionality, identical autonomous underwater vehicles, usually work as team collaboratively, which requires communicating with each other. As you can see in the multi-sync based UASN, there are several communications occurred in the single UASN, so that we can communicate easily through each other. Coming to the routing strategies, you may have doubt how will they route each other through underwater sensor networks. Here are the routing strategies called geo-based routing, source routing, hop-by-hop routing, clustered routing, clause-layered routing, reinforcement learning scheme, opportunistic routing. There are some characteristics. It is based on GPS. The transmission path is determined by the source node called source routing. Coming to the hop-by-hop routing, the next hop is determined by relay nodes. Cluster routing, the nodes are usually divided into groups. In the clause layer routing, it considers the characteristics of other layers. Reinforcement learning scheme selects next hop via an iterative calculation of the reinforcement function. So hereby I can conclude that the underwater sensor networks applications drive the development of underwater sensing, networking, inexpensive computing, sensing and communications have enabled terrestrial sensor networking in the past couple of decades. We expect that cheap computing combined with lower cost advanced acoustic technology, communication and sensing will enable underwater sensing applications as well. So without underwater sensor networks, we can't communicate each other to the countries out of the countries. We cannot even communicate each other with side by side by texting each other. So using optical fiber, the underwater sensor networks are reliable with each other. Without optic fiber, we cannot talk with each other, and we cannot see in the video conference too. While research on underwater sensor networks has significantly advanced in recent years, it is clear that number of challenges still remain to be solved. With the flurry of new approaches to communications, medium access networking, and the applications effective analysis, integration, and testing of these ideas is paramount. The field must develop fundamental insights as well as understand what stands up in the practice. For these reasons, we believe that the development of new theoretical models is very much needed, and that greater use of testbeds and field experiments is essential. Such work will be support more accurate performance analysis and system characterization which will feed into the next generation of underwater communication and sensing. In addition, we are encouraged by broadcasting of the field to consider different options spanning from high performance to low cost and including mobile, deployable and stationary configurations. Thank you. By the end of this video, you might get to understand what are underwater sensor networks and different application scenarios and different routing protocols which I have used, and the network architecture is mainly important for the designing of underwater sensor networks. I hope you understood the topic. Thank you.